In this lesson, I'm going to discuss how different frequencies called harmonics can be produced by the same string. But before we talk about harmonics, let me just review the basic shape of a wave. Now, a wave is called a sine wave. That's this green line over here. Here I drew another one in red. Has a crest and a trough. And as the wave vibrates, what happens is it seems to flip over on itself. The highest most point is called the antinode, and this particular wave drawing has two antinodes because it's flipping, and it has 3 nodes. Now the maximum disturbance occurs at the antinodes. That means that the wave is the highest at that point, and there seems to be 0 disturbance at the nodes. So it looks like nothing goes on at those places, at those locations of a wave. Now we're going to look at the first 3 harmonics produced on a string. There are actually an unlimited number of harmonics, but we'll look at the first 3 and you'll understand the rest. So the fundamental frequency, of course, only has 1 antinode, and we see that it has 2 nodes in it. The natural frequency is also called the fundamental frequency, the basic frequency. And we call that the first harmonic because it's the first in a series. Now, if we take that string and we disturb it at its natural frequency, but twice the natural frequency, what will happen is we will see 2 antinodes appear, and the size of that wave will seem to shrink to half of its size. So we'll end up getting 2 of these bumps. And what happens is we double the number of antinodes and we increase the number of nodes by 1. And we call that the second harmonic. Some people call that the first overtone. That would be very important in music. If you want to talk about the next higher octave, that would be called the overtone because it's 1 and above. Now the third harmonic consists of 1, 2, 3 antinodes and 1, 2, 3, 4 nodes. And that's produced if you take the fundamental frequency and you produce a disturbance 3 times that frequency. So if you disturb it at the natural frequency, you get that pattern. If you disturb it at twice the natural frequency, you get this pattern. And if it's 3 times the natural frequency, you will end up getting 3 antinodes in the pattern. So that's the first, second, and third harmonic. Now harmonics are whole number multiples of the natural frequency. Now, what do you expect to hear? Well, if I'm able to produce this wave right here, this will produce a frequency which is twice the natural frequency. And this one would be 3 times the frequency. So it would be an entire octave higher using the musical terminology.